here that we're going back to working with just sine and cosine functions. So if you guys remember sine and cosine, they were considered periodic functions, meaning once they start, they never do what?
They never stop.
They never stop. They're considered a periodic function, and they keep repeating over and over and over. So are we dealing with asymptotes here at all? No. Okay. And so I think we felt pretty confident with sine and cosine functions when we were working with them. And our job today is to take situations that they give, whether it's data points or whether it's a description of a graph. Our job today is to try and model with trig functions. Okay. Question is, what are the characteristics of the real life problems that can be modeled by trig functions? Realistically, this is what we're trying to do. Okay. If you remember general form of a sine or a cosine function, or in our case a periodic function, it might be y equals a times the sine of b times x minus h plus k, like this, kiddos. Your job really today is this. Once you've been given a function like that, sine might get replaced with what here?
Cosine.
But our job really today, kids, is take the description and then find values for a, b, h, and k. Now I'm going to be honest with you today. Most times h is going to be equal to 0. That won't happen all the time. Okay? Let's just remind ourselves what these values do again. What's a do again? It's like a vertical stretch, or it's the amplitude, okay? What does b affect? Horizontal. So a whole cycle is called a, start with a p. Okay, b affects a period. H is going to translate left or right. And then k, remember, is our midline horizontally. It's the line that the function oscillates around. And we'll talk about that. But our whole job today, guys, is this. Figure out if you're using sine or cosine, and then find values for a, b, x, and h. Okay? So let's talk real quickly. What are our jobs today? Something new. Okay? We're going to have to interpret and use what's known as frequency. This is going to be new for you today. All right? We're going to write a trig function that's like this up here, filling in values for a, b, h, and k. And then this is a cool thing today. When we say use technology, you know you're using what?
Desmos.
It will be Desmos. It will be Desmos to fill that in. Okay? And I'll show you how that works today. Okay? Okay, guys, new vocab term, frequency. Anybody want to volunteer to read that for me?
The number of cycles per unit time of or the reciprocal of the period.
Okay, this is an important one. Okay, anytime you talk about per unit time, it's measured as what's known as frequency. All right, but it also says it's the reciprocal of what? Do you guys remember or recall what the parent function period was for sine and cosine? How we found that? What that formula may be?
2 pi over it.
2 pi over the absolute value of b. Okay. So I'm going to tell you right now, most of the situations we talk about, b is usually going to be positive. It's kind of like saying, how many times can you swing something around, like per second? It's like revolutions per minute. So like revolution typically is going to be a positive value. So if 2 pi over b represents period for sine and cosine, what's the reciprocal of 2 pi over b?
B over 2 pi.
So our frequency, we're going to usually denote a frequency f as equal to b over 2 pi. You're usually going to know the frequency, okay? And they're going to ask you to find a b value to help you with the period of a function right there. So frequency and period are kind of related. They're just what of each other? Reciprocals, okay?
Is it still absolute value?
It can be absolute value. I'm just saying for this, most of the times when they relate to real life situations, the b value we're going to be talking about is going to be positive anyway for that. So if you leave it like that, we should be okay. If you put absolute value b up there, it'll still be okay, all right? You okay with that, El?
Yep.
Okay. One of my favorite math words, sinusoidal. Sinusoidal just means it starts here and it just replicates itself. It just keeps oscillating high to low to high to low. Okay, the only two curves that do that are what and what forms?
Sine and cosine.
If I ever say your function is sinusoidal, you automatically know you're using a sine function or a cosine function. Okay? And it just means it oscillates. That's all it continues to do. All right? Okay. Amplitude. We know what the amplitude is. It's the height above or below the midline. You remember how to find amplitude, kids?
It's
Absolute value of A. All right? Then the period, the time it takes to complete the cycle. Remind me what period for sine, and I'm just gonna write this period for sine and cosine, because it's different for tangent, cotangent. Remember what the period is for sine and cosine?
2 pi over opposite pi.
Yeah. Okay. And then midline, we've talked about midline before. It's the line a sinusoidal function oscillates around. So like right up here in the example I have up top, what's the high it gets to here, kids? 5, and what's the low? If I took 5 plus -1, where are you? 4, cut that in half. 2, the midline would be at 2. It's the average of the high and the low. So like right up in here at 2, here's 1, here's 2. Does this look like a midline right here, or where the graph oscillates around?
Yeah.
Okay, it's the same distance from the maximum to the midline as it is from the midline to the bottom, okay? And keep in mind, the midline represents what value of our function?
Yeah, decay.
K value, all right? Okay, so the two words in the new frequency and what else? Sinusoidal, okay? Not gonna take very long today, I'll be honest with you. This will be pretty short and pretty sweet, okay? I love this first question. It's an interesting one, okay? Anybody want to volunteer to read that for me? Go ahead.
An audiometer produces a pure tone with a frequency f of 1000 hertz cycles per second. The maximum pressure P produced from the pure tone is 20 millipascals. Write and graph a sine model that gives the pressure P as a function of the time T in seconds.
Okay, so we got this time T in seconds. I'm just gonna kind of graph it like this, okay? You know it's what kind of a function, kids? Sine function. So I'm gonna say it's a sine function. It starts out like, goes like that. Does that look like one period of a sine function right there?
Sure does.
Okay. Let's talk, kids. If I have to write a function, we're trying to write a function of the form y equals a times sine of your b value times x minus h plus k. Now kids, in this one right here, I'm going to tell you right now, they're just telling you to use the normal sine function, okay? And what they're telling you guys is this, a couple different things here. They're telling you that there's a certain amount of time t over here. T is going to be measured how on this function? Is it in seconds, I think?
Yeah, it's in seconds.
Okay. All right. And then P of t was going to be the pressure, right? Okay. It was going to be the pressure pure tone. So P of t. Now the frequency that they talk about, kids, is this. The frequency is this. It says the frequency is 1000 hertz or cycles per what? It's saying this frequency or this pure tone happens 1000 times every what? Every what?
Second.
So if I drew 1000 of these back to back to back to back, that would only represent how much time? 1 second. Does that make sense to everybody?
Yeah.
Okay, so if I have 1 second on a horizontal graph right here, and it took 1000 of them, are these going to be really crunched together, or are they going to be really spread out?
Real crunch.
Okay, so let's understand what's going on here, okay? We got to try and find a value for A and a value for B. H and K, not so much. To be honest with you, what's the highest value this is going to get up to for your pressure? 20, which means the lowest should go down to what? Negative 20, right? Okay. I don't know if negative 20 pascals makes sense to me, kids, in real life situation. What do you think?
I agree with Billy.
What do you guys think? You would think the lowest pressure would have to be what value? Wouldn't it have to be 0? Okay. Is there such thing as negative pressure, kids?
Yes.
That's when it's putting pressure outward, I suppose.
Maybe. I don't know. Pressure in and pressure out, is that possible?
Like if there was a numerical value to how much Matt was like squeezing my arm.
Sometimes
If it was
negative
negative,
signs
it means I'm
determine
pushing
direction in
against
science,
my
don't
arm.
they?
It does.
So, is it possible that that could happen here?
Yeah.
spam risk.
That was
Yeah, sure.
the most confusing thing for me in
The
physics.
sea of spam risk.
Was that the negative sign doesn't really mean anything
I
other
think
than
they're
direction.
actually going.
I'll text him.
Pressure can be moving out or pressure can be moving in, so we're gonna stay with it, okay? So what's your amplitude in this, kids?
Or like,
Wouldn't it be 20?
yo.
Oh.
Fiery work.
What's the K value? What's the midline right here, the way we've got this drawn?
0.
So K is gonna equal 0. Are we shifting the sign left or right at all?
No.
So I would make the H value what?
0.
Okay, so we're gonna know that K is gonna equal 0. And H is gonna equal 0. Well. Then we gotta come up with a V value, don't we? Here's the new part. It says there's a frequency of what?
1,000.
Okay, frequency is gonna be new. There's 1,000 cycles per second. So what this tells me, kids, is this. The frequency by formula now is not 2 pi over b, but it's a reciprocal, b over what?
2 pi.
Okay, and what are you gonna replace that frequency value with? What value?
1,000.
So you're gonna have 1,000. How are you gonna solve for b, friends?
Times 2 pi.
Times 2 pi. What's that gonna make your b value?
6.24000.
Okay, or should I just call it 2,000 pi? Is that okay? 2
Yeah.
times 1,000 would be 2,000, right?
Oh yeah.
Times pi would be 2,000
That'd be
pi.
an easy way to do it.
You're like,
my God. My
Okay.
mind's
Quick question. Do I have a value for A?
yep,
Do I have values for K and H?
yep.
So they didn't really talk about it. Do we find a value for B given the frequency of 1,000? Okay. Here's the deal then. Can I write a function of this form? Y equals. What's your A value? Times the B value, or times the sine of B, which is 2,000 pi times which variable?
X minus.
It's really x minus 0, just x, right?
Yes.
Okay. I want to graph this in decimals and just show you what the heck is really happening here, kids. Okay. This would be the graph of this right now. Now think about this. This frequency gets all the way up to positive 20 and then comes down to negative 20. Again, remember everything when you put stuff in, what unit you want to use.
Take this. Hands on that.
Radians, right?
Make it.
Okay, I just want to show you right here. Does this first of all look like a sine function here?
It does.
Okay, I don't know really why stuff is moving around here. Okay, did we get to a high of 20?
Yep.
Do we get to a low of 20?
Yep.
And then do we make it all the way over here? Are you guys good with that? Okay. So there's your graph right there for it. Okay. Now, why 2,000 pi again here?
It's the frequency.
That's the frequency. Okay. So I think that if you can understand what's going on here, getting your 20 right there for your amplitude, your 2,000 pi in there for your frequency, you should be pretty good here. Okay. Let's try another one. This next one's a little more, it's easier. The frequency stuff is tough. The thing you need to understand about frequency is it's now what over what?
B over 2 pi.
B over
2 pi.
2 pi. Okay. All right. Let's take a look at this next one. It says write a function for what?
The
Dinosaur.
Okay. This can either be sine or cosine, can't it?
Yes.
Okay. My suggestion for you is this. I'm going to zoom in on this a little bit and show you what I'm thinking you should do. Okay. I always think starting stuff relative to the x-axis is the most important thing to do. So let me zoom in on this a little bit. Okay.
Is that like a
Do the best I
optical
can
illusion,
here.
or is that line crooked?
I think it's kind of crooked.
Okay.
Okay.
'Cause
If
I
I
wouldn't be
start right
surprised
here
if-
on the y-axis right here, you guys agree the graph starts right here?
Yeah.
Okay. If I follow one cycle through this, it comes all the way down and all the way back up. Wouldn't one cycle look like this right here, kind of a U-shape? That's a really bad
Yeah.
drawing. Okay.
Yep.
Guys, I don't know if you remember on your notes, but do you guys see kind of like this first U-shape I'm talking about right here?
Yep.
Okay. If you remember, I had I think it was 2 sections ago, maybe 3 sections ago. We had like a positive cosine graph that made a U-shape like this. Remember that? And then we had a sine that was positive, and we said it's kind of like a sideways. So it was like a sideways S starting at the origin. Remember that?
Yep.
And then a sine that was negative looked like this. It was just reflected over the x-axis like so. Remember that?
Yep.
I'm going to start a new SnappyGram platform. I'm going to call it cosine negative.
Okay.
Ah.
Cosine negative is a little ghosty.
Okay.
All right. Guys, if you look at this graph right here from where I'm starting, if I do one period from the y-axis over, what kind of a graph does this look like? Cosine or sine?
Oops.
Is it U-shaped or sideways S from these 2 points? So it looks kind of like it's going to be a what? Okay, so let's talk about this graph. Okay, we think it's going to be what? Cosine. Okay, we think it's cosine. Okay, so I'm going to jot that down here. We think it's a positive cosine. Look, the way it starts at the y-axis. So I'm going to write this down. Okay. First thing I'm going to ask about then is the midline. In this graph, what's the highest value it gets to? 13, and what's the lowest? Okay, the midline is going to be just the average of the highest and the lowest. So if I say, well, the midline would be that high of 13 plus that low of -5, and then cut that in half would be my average right there. So what is 13 minus 5 up here, friends?
8.
Divide 2.
Oh.
So my midline is going to be at 4, which is really what value? The K value, okay? So just looking at this right here, I'm going to tell you right now, my vertical axis, everything's counting by 2. So if I would throw a horizontal line in here like so, I kind of already did it right here. That red line right there is my midline. It looks like it's right at what value here, kids? Does it look like this graph oscillates evenly around that line? Okay. So y is 4. Okay, let's talk about amplitude then. Well, guys, if this is the line y equals 4 right here, if the midline's at 4, how far above or how far below are my minimum and maximums relative to that midline? How many units? In other words, to get from 4 up to the highest point, what's that distance right there? So the amplitude has to be what?
9.
Now think about this, the cosine starts on the y-axis. Do I need to move anything left or right at all then? Like everything completely left or everything completely right? Okay, now let's talk about the one period then. Okay, this one cycle time that starts at 0, this one period is going to come back and start over at pi over 4 radians here, isn't it? So if I look at these 2 points right here and say, ooh, what's the horizontal distance for that whole period? Well, what's the distance from 0 to pi over 4? Distance to start at 0 to get to pi over 4. How much distance in between?
Pi over 4.
Okay, so you guys have told me. Now don't confuse frequency with period. The period is the horizontal distance it takes to complete one cycle. Okay? And a period, my friends, is equal to 2 pi over what?
B.
B. Now help me. What is the period then, kids? What was this horizontal distance up here?
Pi over 4.
So the period would be pi over 4 would be the same as 2 pi over what?
2 pi over 8 pi. I don't know.
Close. 2 pi over b, right?
Oh, what?
Now, can I cross multiply both of these?
Yeah.
Wouldn't one cross product be 4 times 2 pi? So this would be 8 pi, wouldn't it? Equals,
I could assume you could.
they told me to b pi today. Okay? They said 8 parts of 1 b pi today. Okay.
Yeah, I said, shut up, go talk to you. Stop doing the you idiot.
I think 3/4 of them missed it anyway.
Oh.
I think they missed that. Like my socks?
Those are pretty nice socks.
I know.
I wasn't saying anything, I was just looking at them.
All right.
I just stare, I don't wanna say,
Yeah.
I don't wanna ruin the moment.
What's that make the b value here, friends?
8.
8. You've done that both sides by pi, b will be 8, won't it?
Yes.
Now, the things that are cool about this when they give you a graph, let me show you what's cool about this. B is equal to 8. So I have the b value, I have an a value, we have a k value for a midline. We said there's not really shifting left or right because the cosine started right at the y-axis, so h really had to be what value, kids? 0. So we think the function for this has to be the following. We think it must be y equals, okay, what was the amplitude again, friends?
9.
We thought it was a positive cosine function, right?
Yeah.
Times b, which is
8.
plus your midline now.
What was it in
I think it was 4, wasn't it? Okay.
Oh.
Why no h value to this?
This is more
We weren't moving anything, we weren't sliding anything left or right. We did some horizontal compression with that 8 in there. Now the cool thing about the graphs and having to write a function for them is this. Once you've done that, Decimals is really super good about this. So we think we came up with y equals 9 cosine 8x, right? Put your parenthesis in, plus what?
4.
Okay, now this is pretty crazy. You guys remember if you click on like the x-axis and y-axis here, you can hold the shift button down and adjust that. I'm going to do that here. I'm going to do the same thing to the x-axis. I can shift that horizontally. I don't want to go that way. I'm going to go this way. Okay. What's the very first point up there on your graph that you knew that we started at? Okay, what other points were listed up there in your graph?
Pi over 413.
Does that work?
Yes.
What was another one?
And then pi over 8 negative 5.
Does that hit?
Yes.
Are we right then?
Seems
So
so.
when you get an answer, if they give you a graph and say these points are on here, this is the graph, can you then go put it in decimals to see if that matches what was given?
Yep.
Okay. All right.
Yep.
What do you say we try another one here? Oh, this is good stuff. I love this stuff. I think it's so cool.
How could I be talking right now?
Okay, friends. Let's talk. What's number 3 say?
2 people swing jump rope as.
Oh, yes. I'm listening, Ellie. Carry on.
Oh, okay.
No,
The
stop.
highest point of the middle of each rope is 75 inches above the ground, and the
Gotcha.
lowest point is 3 inches. The rope makes 2 revolutions per second. Write a model for the height, h, in inches of a rope as a function of the time t in seconds, given that the rope is at its lowest point when t is 0.
Okay, so what's the lowest point to start at here, friend?
3.
And what's the highest point we would start out at?
75.
That is a big.
That's a
The
big.
lowest is-
So kind of what's happening here, kids, maybe you remember your elementary days, maybe you did this in elementary, maybe you didn't, but did you like have a really long jump rope with your friend, one on each end, and then somebody, a third person was jumping in the middle sometimes?
I watched.
Okay? I couldn't do that.
If
I
I
never
did that, I
could.
would have broken
Okay?
my face or something.
So, in this situation, my friends, what is happening here is this. At the start of this right here, what's the lowest value the rope goes to? 3 inches, right? And then the highest it gets to is?
75.
Okay, now.
Terrible.
It says when time t is equal to 0, the rope is at
It's low.
0.
So one cycle might look like this. It's going to start here. Okay, as it rotates around from its lowest point, it's going to get higher. It's going to go all the way up to its highest point here, kids. It's 75, and then what's going to start to happen?
Back down to
Roll
30.
back.
Back down to what?
3.
Maybe 3, and then start oscillating again, right?
How funny.
Uh-huh.
Okay. This look like a positive or a negative something.
Negative cosine.
Okay, so we think this function's going to be negative cosine to model this, right? Okay, that's first. Okay, second question then is, can we come up with a midline for this?
Yes.
Okay. We've got to write an equation that models this right here. The midline, my friends, would be the average of 75 and what? So 75 plus 3 divided by 2. What value is that?
37?
Pretty close.
30.
39. So that's going to be your K value, right? Okay. You guys buying what I'm selling so far? So if this is my midline right here in the middle, ooh, that's terrible. Okay. Kids, this value is at y equals 39, or k equals 39, if you will. How far above and how far below to get to this point and your maximum?
36.
So the amplitude would have to be what then?
36.
Let's see. So this is where things get a little tricky. Is there any shifting left or right that's going to go on at all? No. But then there's this thing, and this is where I really want to make sure we're paying attention. We've used the 75, we've used the 3, we had assigned a low when t was equal to 0. What value haven't we worked with here?
B.
Haven't worked with b. And what number up there would help us solve for b?
Sure.
Read that sentence.
2
Where it
revolutions per second.
says the rope makes what?
2 revolutions per second.
Now is that telling you the period is 2, or is that telling us something else?
Something
I
else.
think it's the frequency,
Why is it the frequency?
because it's revolutions per second.
It's telling us how many cycles happen per unit time, right? So whenever it says like per second or per minute or per hour like that, this automatically, this part right here, this part right here automatically becomes a what? Okay, so from this I would say my frequency f has to equal what value?
2.
But by definition, frequency is the reciprocal of,
Period.
so my frequency would equal b over what?
2 pi.
So talk to me, friends. What are you going to throw in for your frequency value from this?
2.
So I'll have 2 is equal to b over 2 pi. Solving for that b value would make b equal to what?
4 pi.
Very good. B would 4 pi. Okay. We said there's no h value. So my question is, kids, do I have an a value?
Yeah.
Do I have a b value?
Yes.
Yes.
H was 0 and k is what value?
0.
39.
So here we go. We've got y equals. Okay, what kind of cosine function did you want to use? Negative 36 cosine. Times your b value, which is
4 pi.
4 pi times x minus 0, which would just be what? Plus your midline, which is? Okay. Now again, when you get an answer, should you just be satisfied with it, or should we maybe graph it and talk about what's really here?
Probably graph it.
Okay, so let's talk about the frequency of this, kids. If I go in and graph my function, what we just got here was negative 36 cosine, what was it, 4 pi x, friends? And then plus 39.
It's Desmond.
Yeah.
This is the graph I'm working. X equals.
How many revolutions per second? Let's just talk right here. It starts out at a low of what, kids?
30.
Okay, gets to a high of what here?
75.
Comes to a low right here.
3.
That's one whole cycle right there, isn't it?
Yes,
No,
it
it's
is.
at half a second.
Isn't this about where 2 cycles have taken place? I've gone down, up, all the way back down. Down, all the way up, back down. How many seconds did I get 2 whole cycles in here, or 2 whole periods?
1.
The frequency is 2 periods, then, basically, per 1. What's this 1 represent down here?
1 second.
1 second. So it's kind of what's happening there in that graph. Okay. Guys, again, really, you just got to understand, am I using sine or cosine? You got to understand, really you're finding an A, a B. Most of the problems you're going to have, you won't probably deal with an H. We will in the next one. I'll show you how that works. And then the K value is kind of your midline. Okay. Make sense how we're getting them right now?
Yeah.
Okay. Well, the last one's really pretty cool. Okay. The last one, it says use what to help you solve some of these.
That
Sinusoidal.
word, sinusoidal.
Yep. So
Sinus.
you're going to use what's known as sinusoidal regression. Guys, when you see this word regression right here, it means to use Desmos. I'm not going to write it down. Well, I'll see what I can do. I'll do my best. Tell my girls all the time, you guys ready to go to Desmos and see your aunt? She lives in Des Moines. They look at me like I'm weird, which is how you probably look at me too. But that's okay. All right, my friends. It says the table shows the average monthly low temperature D in degrees Fahrenheit in Austin, Texas. Now again, keep in mind we're talking lows, not highs. Okay, gets pretty hot in Texas in the summertime. Where T equal 1 represents what month? T equal 1 represents January. Best month of the year, baby. My birthday, yeah.
The best is February.
Okay, January 6th, that's my birthday. Okay. 3 Kings Day. I was named after a king. My middle name's Arthur. King Arthur. I wonder if I can pull the sword
I
from
was
the
named
stone.
after Connor. My middle name
Arthur
is
Larson.
Okay.
Oh, that is
because it's his name.
All right. Write a model that gives D as a function of T and interpret the period of its graph. Let's talk about this, kids.
No.
In January, what's the average low temperature?
Because the number constants.
Okay, here's how you're going to help me with this. I need to put a table in for this first, and we're going to remind you how to do this. So you're going to want to add a table. So January, first month, what's the low? Average low, 41?
41.
Okay, let's go to February.
245.
45. So it makes sense. It's going to start warming up a little bit, right?
51.
51.
59. 67.
May, average low was 67. June,
72.
72 is the average low. July.
74.
How about August?
75.
September.
69.
October.
61.
November.
51.
Back to December.
42.
And then what do you think the cycle is going to do now?
Go right back around.
Repeat itself. Oh, so let's just take a look at this real quickly. You say 42 was the last one?
Yep.
Okay. So I'm going to try to get these points here to fit. So give me a second. Go temperature 0 to 100. We'll go by tens. Okay, so here's a decent look at this graph. Does that look like something that might be sine or cosine right there?
Yeah.
Okay, now here's the cool part about using sine or cosine for regression. Okay, what I typed in down here is what I want you to write in your notes. Okay, once you've got that table entered, this is what I want you to write down for notes. Okay. So to do regression, recall we have to do the y1 thing. You remember doing that? And then the little squiggle sign like this. Okay. And then you're going to type in A. That's like the amplitude for our function. By the way, what was the low temperature? 41. What was the high? 75. So what's 41 and 75? What's right in the middle of them? If I go 41, 75, that is 34, so 17. 58 is about the middle of those two. Okay?
Yeah.
I'll just tell you there should be a line. I'm just going to kind of type it in here. Is that okay? I'm just going to type in y equals 58 here. That's a pretty close midline to that, isn't it?
Looks pretty close.
Okay. So what you type in here, guys, is you go y1 is approximately a times, this is the the cool part about regression with sine or cosine. It makes no difference what you choose. Okay, you can choose sine or you can choose cosine. I'm going to choose sine on this one. Okay? All right? Then I'm going to go and put a parenthesis. You have to put that parenthesis. Okay? Then you're going to put b and then another left parenthesis like that. Now, this is where part would be x minus h, but you can't do it that way in decimal. So you got to do x1 minus, and you got to stay in order. After b would come what?
C.
Okay, and then you got to have the two sets of parentheses like this. And then finally plus, you can't use k out there. We got to use d. Now, does that graph fit those points pretty well right there?
It does.
Okay, does that 58 look close to a midline?
Whoa.
Yeah.
Check this out, kids. R squared value about what?
0.9. That's pretty good.
So that graph's about 99% accurate here, so we're good. So what's the a value we get for this function here?
That, you covered it.
Okay, I did cosine in the other class. What did we do in this class? Well, what happened tonight still?
Yeah, move from there.
Okay, what do we get for an answer here, kids? I'll type it out right up here. This is what you should have. Y equals.
My house is a
Okay, what's the a value? Should we round nearest tenth? Is that okay, kids?
Yep. 17.6.
17.6 times the sine of, what's the b value about?
0.5.
Times x minus c, which would be x minus 3.9. Oh, my pen is dying.
That's money.
Money dough.
Put that on the
Show me what that money dough.
Plus the k value, which is 57.8. What did we guess midline to be? About 58? Was that right?
Yeah.
Are we close on that? Are those colors messing you up?
No. Never. That's a good shot. Pretty good back. Hey, you got the card.
Okay, that would work. Now here's the deal, kids. Last hour I didn't use sine, I used what? Okay. What do you notice about the amplitude for cosine here compared
The
to that?
same.
Same. What do you notice about the midline?
The same.
Okay, the only things that were maybe a little different were, oh, by the way, the b value was the same, right?
Yeah.
By the way, think about this, the period. This happens every 12 months, right?
Yeah.
Take 2 pi and divide it by 0.5 for me. How about this? It turns out to be about 12.6, so pretty close to 12 months, right?
Yeah.
Repeats itself. Okay. The only thing difference is how far left or right you would shift stuff on this here. Okay. So the regression part, guys, is this: how many sets of parentheses are? How many total parentheses should you really have? And instead of using h and k, what do you need to use?
C and D.
C and D. So we ended up with 17.6 sine times 0.5 times the quantity x minus 3.9 plus 57.8 as a good model for that data. Okay?
Yep.
Sinusoidal just means either sine or what? Cosine. Find the amplitude, find the midline, plug stuff in, you should be good to go. Frequency is new. It's not 2 pi over b, but rather
I 2 over.
b over 2 pi.